So, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 51. Are going to present our case study, which is Batang Kali landslide incident, which happened in 2022. So, first of all, let me introduce our group members. The first one is Nur Fazlina binti Jeffrey. Second one is Q Kibun. Third one is Billy Lim Chepin. And the last one is, which is me, Muhammad Shafiq bin Zurasri. This tragic incident occurred on 16 December 2022 at Father's Organic Farm campsite in Bantakali, Selangor. During the early hours of the morning, a major slope failure occurred, where a large amount of soil and debris suddenly collapsed and buried the campsite area. As a result of the landslide, the disaster claimed 31 lives and left several others injured, making it one of the most serious landslide tragedies in Malaysia in recent years. This incident has raised major concerns about engineering responsibility and slope safety.
I will presenting the background of study for the Batang Kali incident. So, Batang Kali incident happened on 16 December 2022 at Father's Organic Farm in Batang Kali, Selangor. So, it was a recreational farm, and then the affected three camping zones are Hillview, Farmview, and also Riverside. And from the geological context, the landslide type was retrogressive slope failure. And then as we go further, we can see that it's the cumulative rainfall which later increased the soil saturation, also the pore water pressure, and resulted in rapid debris flow that buried the campsite. So, built from this incident, we have experienced 31 casualties.
For this section, we'll discuss the technical and engineering failures that may have contributed to the Batang Kali landslide. The first technical issue is inadequate geotechnical investigation. It is possible that the effects of rainfall and soil saturation were underestimated during the slope assessment. In tropical regions like Malaysia, prolonged rainfall can significantly influence slope stability by increasing the moisture content of the soil. The second issue relates to drainage and pore water pressure. Continuous rainfall increases soil saturation, which causes pore water pressure within the soil to rise. When pore water pressure increases, it leads to a reduction in effective stress and soil shear strength, which weakens the internal structure of the slope. The third issue is lack of monitoring and risk management. In slope engineering, slopes requires continuous monitoring and inspection, especially in areas exposed to heavy rainfall. Engineers typically look for early warning signs such as tension cracks, minor soil movement, or blocked drainage systems, which may indicate developing instability. In this incident, the campsite was located directly below a potentially unstable slope, which significantly increased the level of risk. In this next section, we'll talk about the ethical reasons for failure. The first ethical issue is the duty to protect public safety. In engineering practice, public safety must always be the top priority. Engineers are responsible for ensuring that their designs and decisions do not endanger human life. The second ethical issue was the lack of professional skill and due care. Engineers are expected to apply appropriate engineering standards and professional judgment in their work. This includes considering environmental factors such as heavy rainfall patterns, which are known to significantly affect slope stability in Malaysia. The third ethical issue is accountability and supervision. According to the Registration of Engineers Act 1967, only registered professional engineers are allowed to approve engineering works. This ensures that engineering projects are designed and supervised according to professional standards. The final ethical issue is risk communication. Engineers have the responsibility to communicate potential hazards clearly to stakeholders and authorities. Stakeholders should be informed about slope instability risks and the necessary mitigation measures so that appropriate actions can be taken.
So, our recommendation for us to prevent incident like Batang Kali to happen again is we can conduct mandatory geotechnical audits for hillside developments. With this, we can track on the spot the condition of the hillside developments. We can also install real-time slope monitoring systems and ensure proper land use planning, hazard assessment, and lastly, we can also implement early warning system (EWS) based on the rainfall threshold.
In conclusion, the Batang Kali landslide showed the serious impact of geotechnical failure on public safety. The disaster occurred due to both natural factor and engineering weakness. Heavy rainfall increased poor water pressure and reduced the strength of the soil. At the same time, limited site investigation and poor slope management also contribute to the failure. This incident highlights the most important of strong engineering practice, ethical responsibilities, and continuous slope monitoring to prevent similar disaster in the future. This is the reference part of our presentation. That's all for our presentation. Thank you.